So examples 2 and 3 are done, or 1 and 2 are done. Here's 3 and 4. So again, we're only looking at domain values. Domain values are our possible x values. Remember, our x is our vertical axis here. Can this graph have an x value of 0? Yes, crosses the graph right there. Can it have an x value of 1? Yes, right there. X value of 2? Yes, right there. 3? Yes, right there. Can it be 8 way out here? Sure. Eventually, because this is continuous, because it has that arrow, because it has that arrow, this is going to continue up all as far as it can go. So eventually it would hit 1,000,000. What about negative? -1. Yes. -2. Yes. -3. Yes. Just off the graph, but it would cross right here. And again, -1,000,000. Sure. Infinity. Absolutely. So this graph is continuous, both directions, positive and negative, on the x-axis. Therefore, we can say x's domain is all real numbers. Okay. And for range, we do a similar process. Can our range value have a y value? Our y-axis is the horizontal or the vertical one. Can it be 0? Yes, crosses right there. Can it be 1? Yes, crosses right there. Can it be 4 or 3? I mean, right there. 5, right there. Can it be 1,000,000 way off the grid? Sure, eventually, because this arrow is pointing up, it's going to continually go up. Same with the other way. -1, -2, negative whatever would be right here where it crosses. And again, way down here in the millions, absolutely. Eventually it would get there. So x can be everything. Or not x, I mean y. Our range can be y's range is domain. Our range is all real numbers. And again, remember there's 2 or 3 different ways to write that. Pick one, go with it. Don't intermix. Don't say x's domain is this and y's range is all real numbers. Okay? Don't mix that. It's not absolutely wrong. Just pick a method and kind of try and stick with it. But just realize that there are different ways to write it, so you may see different answers from one source to the next. Graph number 4. Domain. What possible x values can this graph have? Can it have a graph, x value of 0? Yes. 1, 2, 3. Yes, it would eventually cross over here. -2, -3, -4, wherever it is, eventually cross over here. And again, these go out completely to infinity this way and this way, left and right. So our domain, possible x values, are going to be everything. X's domain is all real numbers. Then we look at our range, our possible y values. Remember, our y is this axis, our vertical axis. Okay. Can we have y value of 0? Yeah, actually 2 of them. One here, one here. Can we have a y value of 3? Yes, again, 2. How about 4 or 5? Yes. Can we have one way up here at like 8? Sure. Eventually these lines would cross and we would have y values up there. What about negative? What about -1? Sure. Absolutely, right there. -2? Right there. -3? Oh, no, not -3. So what's the lowest possible y value that we could have? Well, it's that y value right there. -2. Right there. So how do we say that? How do we say that the range is -2 and bigger? Well, we simply say y has to be greater than or equal to -2. And simply done. What's our time on our video here? Oh, let's do 5 and 6 in this one as well. Example 5. Here we go. We have 2 parts of a graph now. These, you have to understand or realize that these are called asymptotic. I can't even spell that right now. A-S-Y-M, asymptotic. Okay? They get infinitely close to infinitely close to this line here, but never touching. Never touching. So this line is 0 for x, this line is 0 for y. So these lines will forever get, if I could blow this up, they will forever get infinitely close to, but never touch that line for as far as you could possibly imagine. Okay? You can get super close to 0. 0.00000000001 is not 0. It's really close, it's not 0. So these are asymptotic. So with asymptotic graphs, we got a little bit of a different situation happening. Okay? So let's first look at domain. Domain, again, remember, are possible x values. X values are these ones. Whoops. Or these ones. Can we have an x value of 1? Yes. 2? Yes. 3? Sure. How about 50? Way out here. Yes, this graph will eventually hit it. How about -1? How about -2, -3, -50? Yes, this graph will eventually hit it. How about half? Sure. About a quarter? Yes. How about -0.0000001? It's going to be super close to 0, but not touching it. And that's what we're looking for. Okay? So really, our x-axis, our domain values can be everything, both positive and negative, both positive and negative, everything except what value? Except this value right here, this value of 0. So we simply say x's domain is all real numbers, but x cannot equal 0. Okay. And if you're astute enough and you're kind of picking this up a little bit, you'll see that, okay, if we look for range values, here's our range values. Getting infinitely close to this line can be completely negative as far as you want to go, can be completely positive as far as you want to go, but never touching this line, and this line is a value of y is equal to 0, infinitely close but never touching. We say y's range is all real numbers except that y, whoops, not x, y cannot equal 0. And we leave it at that. And example 6. Again, a couple, oh, that's the same graph. I wonder if the graph in your book is the same. If the graph in your book is the same as this, well, then I'm sure it is. Then let's just skip it. I may have to show you a different one in class. All right, so we just skip this one because it's exactly the same.